In a lab in Moscow, a team of scientists did something that should not have been possible. They took a tiny system, moving forward through time, the only direction time is supposed to move, and they made it go backward. Not a simulation, not a metaphor, a real quantum machine coaxed into unhappening. For a fraction of a second, the effect came before the cause. And when the results were published, something strange happened. The physicists who read the paper didn't celebrate. They got angry. Because what that lab had built wasn't just an experiment, it was a crack, a small, deniable crack in the one wall of the universe we were told could never break. And once you see the crack, you start noticing it everywhere. Here's what you were taught in school and what almost every physicist will still tell you with total confidence. Time only moves one way. Forward. Always forward. Coffee cools, glass shatters, you get older. Never the reverse. This is called the arrow of time, and it's baked into something called the second law of thermodynamics, the idea that disorder, entropy, only increases. It's one of the most trusted laws in all of science. Stars obey it, cells obey it. You are obeying it right now, in this exact second, as your body quietly loses the fight against decay. So when a small group of physicists in Russia decided to test whether that arrow could ever bend, even slightly, most of their colleagues assumed the answer was obvious. It couldn't. They ran the experiment anyway. They used a quantum computer to put a group of particles into an ordered, young state. Then, they let entropy do its job. Let the system decay, spread out, forget itself. Exactly the way the universe always does. And then they tried something almost absurd. They asked the computer to reverse it, to take the disordered, aged state and undo it. Push it backward. Make it young again. By the rules everyone had agreed on, this should have failed instantly. The odds against it happening naturally by pure chance in a system that large were described as worse than the odds of all the air molecules in a room spontaneously rushing into one corner and suffocating you in your sleep. It shouldn't happen once in the lifetime of the universe. It happened, repeatedly, on demand. At first, the explanation seemed almost comforting. This wasn't time travel in the science fiction sense. No one was going back to meet their younger self. It was a tiny, isolated quantum system engineered under laboratory conditions that don't exist anywhere in nature. A parlor trick of algebra, some said. Nothing to see here. But then something strange happened. Other labs started replicating pieces of it, not exactly the same experiment, but the same unsettling family of results. Photons, taking paths that seemed to know in advance which measurement would be made on them later. Systems where the future measurement appeared to influence the past state, at least in the mathematics, at least on paper. Physicists have a name for this uncomfortable zone. They call it the measurement problem. It's been sitting quietly at the foundation of quantum mechanics for a century, mostly ignored because ignoring it let everyone keep building phones and lasers and GPS satellites without going insane. But this is where everything changed, because once you show, even in a sealed box in a Moscow basement, that the arrow of time can be pushed backward under the right conditions, you've done more than win an argument about entropy. You've suggested that the flow of time might not be a law of the universe at all. It might be a property of us, of memory, of the way a mind built for survival is forced to experience information, one direction only, because that's the only direction that helped our ancestors avoid the tiger and remember where the water was. And that wasn't the worst part. The worst part came when someone asked the obvious follow-up question. If time's arrow can, in principle, be reversed in an isolated system, what stops a large enough system, with the right technology someday, from doing the same thing? Most physicists answer instantly. Practically, nothing could ever reverse something as large as a human brain, a human life, a single afternoon. The scale is unthinkably too big. The odds are, for any purpose we care about, still zero. But notice the word they used, practically, not impossible. Practically impossible. And this is the part almost nobody talks about, because it's the part that makes serious scientists uneasy in a way that has nothing to do with math. If the flow of time is not a hard law, but a statistical one, a rule that holds almost everywhere, almost always, for reasons of scale rather than principle, then the past isn't gone. It's just extraordinarily, overwhelmingly unlikely to come back. Unlikely is not the same as impossible. And once you know something is merely unlikely instead of forbidden, You can't stop thinking about it. That's why the physicists were angry. Not because the experiment was wrong, because the headlines that followed it, scientists reverse time, time travel achieved, collapsed a century of careful, humble uncertainty into a single, reckless sentence. A sentence that sounded like a doorway. They weren't angry at the discovery. They were angry that the public had just been shown the doorway without anyone explaining what stands on the other side of it. Here's the thing this story is actually about. It was never really about quantum computers or entropy or a lab in Moscow. It's about the fact that every single one of us is already living inside this exact paradox. You experience time as a river, one direction, unstoppable. The version of you that existed 5 years ago is gone, sealed off, unreachable, and some part of you has quietly made peace with that because the alternative is too much to hold. But physics has never actually promised you that river only flows one way. It has only ever told you that reversing it is staggeringly improbable. That your unwound past, your unmade mistakes, your unsaid words, they aren't erased from the universe's rulebook. They're just buried under odds so enormous that no human mind was built to feel the difference between impossible and impossible in practice. And maybe that's the real reason this story unsettles people more than a headline about a Russian lab should. Because most of us don't actually fear that time travel is real. We fear that it isn't and that we are stuck permanently on this side of every decision we've ever made. The scientists in that lab weren't chasing time machines. They were chasing a much older, much more human question, just wearing the disguise of physics. Is the past truly gone? Or are we simply too small, too slow, too temporary to ever get back to it? Every civilization has built its own answer to that question. Religion called it eternity. Physics calls it entropy. Grief calls it the thing you can never undo. They might all be describing the same wall. So, no, we haven't built a time machine. No one is going back. But somewhere in a quantum computer, for a fraction of a second, the universe forgot which direction it was supposed to move in, and for that fraction of a second, the wall between what happened and what could still happen got a little thinner. Maybe that's what actually terrifies the physicists. Not that the past might come back, but that it was never really gone. We were just moving too fast in one direction to notice it was still standing right behind us.